Athletic physics.
Sports!
Projectiles launched at an angle.
When an object is launched at an angle, its components can be separated into two different parts, horizontal and vertical. The ball began on the ground and was kicked with an initial velocity. Once Nate kicked the ball, like the soccer champ that he is, the ball begins accelerating in the vertical direction as well as a horizontal direction and moves. Sports!
Free fall. The tennis ball that is held within Jacob's hand begins at an initial velocity of 0 meters per second and a height of 1.47 meters. There is no motive power for the ball. Gravity was always trying to pull the ball out of his hand and towards the ground, but the force of Jacob's hand pushing up against the ball was equal and opposite to the force that gravity had on the ball. So, the ball remained in place. Now the tennis ball is moving with a constant acceleration.
Sports!
Acceleration.
By definition, acceleration is a change in velocity and or direction. In this example, Jacob kicks the ball to Jake, who then changes the direction of the ball by kicking it at a different angle, as well as changing its velocity because Jake kicks it harder than Jacob, who passed it to him. Same with this softball example. Sports!
Newton's first law. Newton's first law states that an object at rest will remain at rest, and an object in motion will stay in motion at a constant velocity unless acted upon by a side force. This is called the law of inertia. The goalie was the outside force that stopped the ball that was in motion. In this situation, the outside force was the locker, stopping the girl's motion and the gravity taking over and pulling her towards the ground because her initial velocity became too weak to counteract the force of gravity. This can also be seen in everyday things like throwing a ball. If the ball were thrown without forces like gravity or air resistance, the ball would keep moving on forever. However, outside forces allow the ball to stop. Newton's second law. Newton's second law shows the direct relationship between acceleration and net force. Jacob pulled the rope in the negative direction with the same amount of force as Michelle pulled the rope in the positive direction, which is seen through the lack of movement in the bag that is tied to the middle of the rope. This equal relationship in forces results in scientific equilibrium. Newton's third law.
Newton's third law states that if one body exerts a force on another body, the second body exerts on the first body an equal force in the opposite direction. One tennis ball exerts a force on the other, and the second tennis ball exerts an equal but opposite force on the other and move in the opposite direction they came from. Mass does not affect the force applied. Two different sized balls apply the same amount of force to each other independent of their size.
Rolling down ramp.
Net force on an object causes acceleration or a change in an object's velocity. Contact forces include physical contact, applied forces, normal force, friction force, and tension force. Field forces exist in the absence of physical contact. The soccer ball being rolled down the ramp has a gravitational, normal, applied, and frictional force into effect, causing the ball to roll down the ramp.
Projectiles launched horizontally. The soccer ball is at rest until Jacob kicks the soccer ball. Once the ball leaves the surface of the playground, the only force acting on the ball is gravity. The horizontal velocity of the soccer ball remains constant throughout its time in the air. Newton's first law explains why the ball has a constant speed because the ball will continue to move in a constant speed until stopped by an outside force, considering negligible air resistance. The vertical velocity is increasing as the ball travels down because it's accelerating. Gravity has an effect on the ball, which brings it down. Constant velocity.
Average velocity equals displacement divided by the amount of time it took to undergo that displacement. So in order to calculate, we would take the distance which the car traveled in meters and divide it by the amount of time it took to go that distance. In this clip, Jake's car was traveling 11 miles per hour, 4.9 meters per second in the south direction. Constant velocity is a vector quantity, and because the car was not changing in speed, we can say that the car was constant.
Revolving. The definition of revolving is when something is moving around a central point. In this example, the central point is Nate. As the hula hoop moves around Nate, it has a centripetal force pointing at him. The reason the hula hoop drops is because gravity is constantly tugging on the hula hoop, which is resisting this force as Nate moves it around himself.
Sports!
On the tire, the little white tag is revolving around the central point, while the actual tire is rotating around the central spoke. Rotating.
Jake is rotating around an axis located under his right foot. His left foot is making a slow but sure rotation around the axis. In this rotation, time and radius are not related because as time progresses, the radius of the rotation stays the same.
Sports! 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 Sports!
Done.
Average velocity equals displacement divided by the amount of time it took to undergo that distance. So
My turn.